Hello, this is Miss White, and today we're going to be doing lesson 18, computing actual lengths from a scale drawing. This means that we will be identifying scale factor. Now, the goal is for us to understand how to calculate the actual length of a scale drawing. Example 1. Vincent proposes an idea to the student government to install a basketball hoop along with a court marked with all the shooting lines and boundary lines at his school for students to use at recess. He presents a plan to install a half-court design as shown below. Da-da-da. After checking with the school administration, he is told it will be approved if it fits on the empty lot that measures 25 feet by 75 feet on the school property. Will the lot be big enough for the court he planned? Explain. Now, here is our scale factor drawing. We have 1 2/3 for the width and 2 inches for the length. Now, our goal is to calculate what the actual dimensions would be using 1 inch on the drawing that corresponds to 15 feet to the dimensions of the empty lot, which is 25 feet by 75 feet. Now go ahead and pause the video to create the table that I have made below. We have drawing length and actual length here, and then scale length and width. All right, now that you have made your table, let's start filling it out. So above our scale factor picture here, it says the scale drawing is 1 inch on the drawing correspondence to 15 feet of the actual length. So for the drawing length, we are going to put 1 because it represents the 1 inch. And then for the actual length, we're going to put 15. Also, we know that the width is 1 2/3 inches. So let's put that down for width. And then the length is 2 inches. Now, looking where it says scale on our chart, we can see, okay, we have 1 and 15. And to get 1 to 15, that means that we have to multiply it by 15. That is going to be our constant of proportionality. So K equals 15. So now that I've done it here, I'm also going to do it here and here. So I have 2 times 15, and that's going to give me 30. I have 1 2/3 times 15. And if we do that off to the side over here, we will have 15 over 1. That equals 15 times 1 2/3. Let's turn 1 2/3 into an improper fraction. So now we have 15 over 1 times 3 times 1 will give us 3, plus 2 will give us 5. 5 is our numerator, and our denominator stays the same, which is 3. Now, go ahead and calculate in your calculator 15 times 5. All right, you should have got 75, and then 1 times 3 is 3. Now, if we take 75 and divide it by 3 on our calculator, we will get 25. So now our width is going to be 25. We have to understand that we're going from inches to feet because in our calculation up here it says 1 inch for 15 feet. So now we have 30 feet for 2 inches and 25 feet for 1 2/3 inches. Now that we have figured out our dimensions in the table, we need to look back at what our question is asking us. So we know that the lot that this needs to fit on is 25 feet by 75 feet. Will the lot be big enough for the court he planned? The answer will be yes, because 30 feet by 25 feet is less than the given dimensions. Let's move on to example 2. Example 2. The diagram shown represents a garden. The scale is 1 centimeter for every 20 meters. Each square in the drawing measures 1 centimeter by 1 centimeter. Find the actual length and width of the garden based upon the given drawing. Go ahead, pause the video, and create the table below that I have made. Now we're going to fill this in together. So first we have our drawing length. This represents the actual drawing where each square in the drawing measures 1 centimeter by 1 centimeter. Then we have our actual length, and that represents the 1 centimeter for every 20 meters here. Now let's put in our scale, our length, and our width. Our drawing is going to be represented as our X, and our actual is going to be represented as our Y. Now with our scale, 1 centimeter is 20 meters. So for our drawing that we see here, I am putting in this box 1 centimeter. Now our actual is 20 meters, so we're putting 20 meters. Now let's put the length and width for this drawing. So our width is here. We have 1, 2, 3, 4. So we have 4 centimeters for our width. And for our length, we'll have 1, 2, 3, 4, 5, 6, 7, 8. So we'll have 8 centimeters for our length. Now we want to look at the relationship between our scale to determine the length and the width. So I have 1 centimeter going to 20 meters. That means I'm going to multiply this by 20, because I know 1 times 20 will give me 20. Now, when I do it here, I need to do it to my other X values. So I'm going to say times 20 times 20. If you want to put the arrows, go ahead. Now, get out your calculators if you need. We have 8 times 20. That'll give us 160 meters. And then we have 4 times 20, which will give us 80 meters. Now, let's revisit this problem just a little bit. I want you to understand that we have this picture here, and every box is 1 centimeter by 1 centimeter. We are trying to find the actual length. So that means that we are doing an enlargement. We're taking a smaller product and making it into a bigger product. Now, as we can see here, we have got the actual length and width, which it asked in the problem here, because we found our actual. So our actual length is 160 meters, and our actual width is 180 meters. All right, turn the page and let's move on to example 3. A graphic designer is creating an advertisement for a tablet. She needs to enlarge the picture given here so that 0.25 inches on the scale picture corresponds to 1 inch on the actual advertisement. What will be the length and the width of the tablet on the advertisement? Go ahead and pause the video to create this table here that I made below, and then we will fill it out together. So first we have our picture, which is going to be our X value. And then we have the actual advertisement, which is our Y value. Now let's look at the problem again. It says she needs to enlarge the picture given here so that 0.25 inches on the scale picture corresponds to 1 inch on the actual advertisement. So here for our scale, our picture is 0.25 inches and the actual advertisement is 1 inch. Now let's add the picture measurements to the table. So for our length, we have 1 1/4. So first we need to label our length, and our picture is 1 1/4 inches. Now we're going to look at our width here. We're going to label in our table width, and our width is 1 1/8 inch. Great. Now let's find our constant of proportionality, which is known as our unit rate. We would set that up as K equals Y over X, because remember K is, we're looking for the constant of proportionality, also known as our unit rate. So now we're going to take our value from our picture and our actual advertisement. So in this case, our Y value is 1 over our X value here, which is 0.25. Now go ahead and get out a calculator and put 1 divided by 0.25. All right, after you are done calculating, you would have gotten 4. So K, our constant of proportionality, equals 4. Now, ideally, if we want to look at this visually, we know that 0.25 inches times 4 equals 1 inch. We're also going to do these to our other values, times 4 and times 4. Now let's calculate our values. So our first value is 1 1/4. If we want to, we could turn that into an improper fraction, or we could take our calculator and say 1.25 times 4. Go ahead and calculate that in your calculator. Great. You should have gotten 5. So the actual advertisement for length is 5. For the width, you can turn 1/8 into a decimal, or you could turn it into an improper fraction. So if we were going to turn it into an improper fraction, we have 8 times 1, which gives us 8, plus 1, which gives us 9 as our numerator, over our denominator of 8, which stays the same, times 4 over 1. And we have 9 times 4, which gives us 36, over 8. Now, if we were going to turn this into a mixed number, 8 goes into 36 4 times, and we have 4 left over, and then keep 8 as our denominator. Now we can see this fraction here can be simplified, and we can simplify it down to 4 1/2. So now we know that our width is 4 1/2 inches. Now let's use the problem that we just completed as an example. What does the scale factor tell us about the relationship between the actual picture and the scale drawing? Well, it gives us an understanding of how much larger or smaller the scale drawing is compared to the actual picture. That's why in this case We have our picture, and then we have to actually figure out the real size of what is in, or the enlargement of our picture. How does a scale drawing differ from other drawings? Well, in a scale drawing, there exists a constant ratio, which we can see here, of a scale drawing length to actual length, whereas other drawings may not have a constant ratio between all corresponding lengths of the drawing and the actual picture or object. All right, 7th grade, great job today. Great job keeping up on these videos, and I will see you in class.